In this video, I'd like to talk about the math question of the day for Tuesday, June 13th, 2023. And with this problem, we need to find the inequality represented by the graph. And linear inequalities are typically taught in an Algebra 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And the general strategy is that we first want to figure out the equation of this boundary line, and then we can use the shading information to determine the inequality. We will also need to consider whether or not this is a solid line or a dashed line. But we'll come back to the inequality part at the end. Let's first start by just finding the equation of this line. And remember that a linear equation we can write as y is equal to mx plus b, where this is our slope-intercept form, and the coefficient on x, m in this case, this is our slope, which remember is defined as the rise over the run, or you could think of it as how much the y values change divided by how much the x values change. This delta here, this Greek letter, just means change in. So change in y divided by change in x. And b in this equation, this is our y-intercept. Since if you plug in an x value of 0, notice that this simplifies to just y is equal to b. So we can use slope-intercept form to figure out this equation here for this line, this blue line here. And we can see the y-intercept right here. When x is equal to 0, y is equal to 1. We have that coordinate point, so we know our b value. We can write that b is simply equal to 1 in this case. And we just need to figure out our slope. And we can do that by just counting. We can look at how much between 2 points the line here goes up or down, and how much it goes left or right. And it looks like it goes down 1 unit and to the right 3 units. So we can use our rise over run. We can say m, our rise is -1, we're going down, and our run will go to the right 3 units. So the slope is -1/3. And with b and m, we can just plug these into our slope-intercept form and write our equation of the line. Y would just be -1/3, which is m, multiplied by x, plus b, which is +1. Now, for this particular problem, it was easy to find our y-intercept since that point was explicitly told to us. However, if, for instance, we had a different point, maybe somewhere right here, and the y-intercept was not completely clear, we would have to use a slightly different method. We could use point-slope form in that case, where as long as we know the slope and one of the points, we can rederive that equation from point-slope form. So that is also useful, but in this case, we could use slope-intercept form since we knew the y-intercept. Now, keep in mind that this is just the equation of this blue line. This does not yet describe the inequality. To describe the inequality, we need to consider the shading and the fact that we have a solid line. If the line is solid, we're dealing with greater than or equal to or less than or equal to. But if we have a dashed line, then we lose the equal sign. Essentially, it could be greater than or it could be less than. And from here, since we know that we have a solid line, we can narrow it down to one of these. And since the shaded region is less than the line, we would say that y is less than or equal to this -1/3 x plus 1. So this right here would be our final answer, but we can test it by just picking some point in the shaded region and showing that our inequality would be true. And we could pick something simple. Let's just pick the origin here. We can plug in 0 for x and y, so that we would get 0 is less than or equal to -1/3 times 0 plus 1, which simplifies to that 0 is less than or equal to 1, which of course is true. And any point you pick in this region, when you plug in that point to this inequality, you would find that it's true. So that helps us feel confident that this right here is the inequality that is represented by the graph.